I've been enjoying getting myself ready for this talk. Hopefully it will work for everyone. Feel free to ask questions at any time. If Julie and Alyssa could monitor the chat and let me know if there's anything that I should get to, that would be great. Before we start off, happy Pi Day, everyone. I grew up in Scotland and we didn't have Pi Day. We probably had Eve of Ides of March. We do the day first and then the month. So it was 14.3 instead of 3.14. So never knew I was missing out until I came to America. All right. So tonight, what I'll be talking about is basically a review of carbon, looking at some carbon and the influence on climate change, then looking at forest carbon pulls and flows, and then last off, something I think most of the landowners on the call might be interested in would be the current forest carbon markets and what the emergent markets are looking like. All right, so let's get into the carbon chemistry. I basically had forgotten what a unique element carbon is. It's the basis of almost all life on Earth. If you remember your periodic table, it's atomic number 6 and a valence of 4. And as a pure element, it can take several forms: diamond, graphite, and fluorines. And I must admit, fluorines I hadn't heard about until I was preparing for this talk. I think they were discovered in 1985 after I'd done my organic chemistry at university. So it's kind of fun to know that science is learning new things all the time. It's a non-metal, and carbon can bond with more elements than any other element. And as I was saying, it's got a major influence on our climate. Here's the structure. Basically, you can see that the 4 valences in the outer ring. Typically, you can pack 8 in there, so there's 4, so it can bond with a whole bunch of different things. From a structure point of view, it's kind of wild to think that it can form one of the hardest element structures on the planet in terms of diamonds, and then one of the softer elements in terms of graphite. It's all to do with how these bonds are arranged and how many carbon to carbon atoms are joined together. This is a picture of I don't even remember how fluorines got found. Basically, I think that this one's called a Buchenmeister fluorine. It's a C60 combination. It sounds pretty cool, but I don't know how many I've come across. Almost like a soccer ball pattern to them. Okay, carbon also has some fundamental reactions that are key for us, being photosynthesis and respiration. Basically, photosynthesis needs to have a catalyst to help move carbon dioxide and water to sugar and O2, which is key. And then on the other side, the respiration is basically having the sugars and oxygen converted to carbon dioxide and water, and basically releasing the energy that was stored in there. And in plants, there's a diagram up that says day and night, but essentially cellular respiration happens all the time. So it's basically the day photosynthesis that needs the sunlight to go, but it's a very what's the word, straightforward diagram, and I thought might be useful for folk to see. Basically, the sunlight helping oxygen and carbon to carbon dioxide. Carbon dioxide and water to make sugar and liberate O2, oxygen. And then when you get to carbon and its form in trees, it's basically, there's two kind of main elements that you see, cellulose and hemicellulose. Cellulose is pretty simple. It's basically sugars bound together, and hemicellulose, the middle one, is slightly more complex. But the cellulose content for wood is roughly about 40 to 50% of dry wood weight, and the hemicelluloses range from 25 to 35. Another major component, one that's always interesting, is lignin. And lignin, there's basically 3 different types bonded together in various arrangements, and it's a little bit of an issue when people are using trees as a feedstock for chemical reactions. But I thought you might just enjoy seeing some of the compounds or the structures there. As we go forward, we can think about wood as being useful in so many different ways. As the relative cost of fuel source is changing, there's always a question about how to use wood instead of oil or coal. And just today I heard that there was interest in Shell in purchasing 6 biomass energy plants in Maine. This comes from one of the most reliable sources on the planet, which is a Woods truck driver. They've been known to get ahead of so many different bits of information that, so as I was saying, it's the first time I've heard about it, but who knows, that could well be right. Unfortunately, I've got a link with a YouTube here that I tried to fire up earlier on today, and it basically didn't work. I'll post that in the chat for you to catch up with, but it's some of the work that's being done at the University of Maine in the Forest Bioproducts Research Institute. They basically have a scaled up laboratory where they can do all kinds of different things, such as turning cellulose into jet fuel. So the innovation there is really quite interesting. Another major thing going on is, thank you, Julie, for setting that up. In terms of innovative wood products, the use of nanocellulose, basically derived from wood. Again, the University of Maine is a world leader in preparing this product and ships it out to all kinds of different places where folk use it to perform different things, like adding it to cement and increasing the durability and strength of cement. All right, here's a pop quiz. Does anyone know this compound? It's basically a hydroxyl is attached to a carbon atom on an alkyl group.
Ethanol.
It is an all, that's for sure. It's ethanol. Well done. Who said that? As I say, one of the few times that an alcohol is the answer. I appreciate that. Well done. I should note that no brain cells were damaged in the creation of this illustration. Okay, moving on, we'll get to carbon and climate change. So carbon is both a component of carbon dioxide and methane, which have been proven to be greenhouse gases. And trees and forest products have been identified as ways to help reduce the concentration of carbon dioxide in the atmosphere. A lot of research and work is being done in that field. It's basically entering in a lot of conversations these days about how best to manage forest and forest products, and looking at the life cycle of carbon in various things. Just as a reminder for folk, basically, what is a greenhouse gas? Essentially, what goes on is sun rays come through the Earth's atmosphere, gets absorbed by something on the surface, and is re-emitted at a different wavelength. And that wavelength is more easily be stopped from leaving the atmosphere by carbon dioxide or methane. And there's some others as well. I think there's like 4 different greenhouse gases that they're talked about. And essentially that's what's been thought to leading to Earth warming up. I'll keep up with my notes here. Now, I'm not an expert in how they got estimates of carbon dioxide in the atmosphere, but basically it's been bouncing along between 200 and 300 parts per million, which, if anyone's thinking about it, it's not really a huge amount of carbon dioxide in the atmosphere, but it does have quite a presence when it comes to trapping that radiation. And as you can see, over time, it's basically bouncing along. And I don't think it's quite evident by this slide where we are now. Let me try and draw a little bit. You can see that now it's saying in 2020, the average was 412.5 ppm. So it's really quite a deal in terms of how that carbon has changed. And you might be questioning how they found that. And basically, I've got a story. It's one of the few times that ice in my whiskey held part of the answer. In that when I turned 50, I've got a friend who was a glaciologist, and he took ice cores back from the Antarctic. And as a treat, he took along some cores that were no longer being sampled at the university, and we popped some in our drinks. And these cores were something like 10,000-year-old ice, which was quite amazing. On that occasion, I'm afraid some brain cells might have been damaged. It was a birthday party after all. More recently, there's some back in, I think it was 58, the Scripps Institute of Oceanography set up atmospheric sampling on the top of the mountain Maui, which is on the big island of Hawaii. And essentially, they've been tracking the increase in carbon dioxide in the atmosphere since that time. So it's been going up at quite the lick there. And it's interesting to look at it on a finer scale. If you look at the red line, it pops up and down, and that's in lockstep with how the northern hemisphere forest captures carbon, with the leaves coming out and capturing carbon and then dying down. So it's quite an interesting response there. So recently, as I was saying, there's a lot of concern about how that carbon in the atmosphere is influencing our climate. And in Maine, there's been a lot of effort basically trying to get everyone to act now. I must admit, when I first started hearing about, or first saw that CO2 chart, it was back in the early 1990s, and we've done as a species, we've done an awful job of trying to look at that and trying to control it. But now there seems to be some more traction. People are getting concerned about it, and with everything else, you need data to be able to manage. So a whole pile of research recently has gone on through the state of Maine and federal government to try and get a handle of where things are and what we might be able to do about it. This chart is indicating where the emissions of fossil fuel combustion in Maine is occurring, where it's coming from. And it's from the Center for Research in Sustainable Forest at the University of Maine, but it's a very collaborative effort with quite a lot of people participating in it. One of the bottom lines, you can see transportation is a good chunk of, I think it's something like 4.9 mega-million tons of carbon per year, and about 2 of that's coming just from transportation. So at least this has given us an idea of where we might think about looking to try and reduce our carbon footprint. Also in that research, it shows this. I love this. It's like everyone during every presentation has to show up something that they know people have got not a hope in heck of sorting through. And this is my one. Basically, it's showing that the work they did looked across so many different sectors. And this is just a small sampling of the work they did to come up with these numbers. But you can see that the forests are considered to be a net uptake. In fact, I've heard 10 to 20% is what forests have been able to do to absorb some of that carbon dioxide. All right, getting into forestry itself. Where is the carbon and how does it move about? And essentially, there's to make things simple, folk have broken it out into pools and flows or fluxes. And the pools basically are seen, I broke them out to live above ground, live below ground, dead above ground, and dead below ground, as well as stored in forest products. So many different people have subdivided or looked at it in different ways, but for my mind, that kind of worked. Obviously, there's the vegetative part as well as the different animals and also the within the mineral side of things, just basically carbon not associated with the biosphere at all. So it appears in many different ways, and how you the University of Massachusetts and University of Vermont clubbed together 2 of their scientists there and came up with kind of how much might be considered to be an average of in some of the different forest types we have in this area. I put the link there for anyone who wants to go and take a look at it. It's quite a good publication. I quite enjoyed reading it. But the breakdown of how much is in the soil organic, live above, live below, deadwood, and litter is there for folk to see. And it's fairly consistent across the different forest types. Northern hardwood, the 77 metric tons per acre. The oak pine, slightly more in metric tons. That tends to be more south too, so I would assume that there's a little bit better growing going down there. And then the spruce fir, slightly less at 7.9 there. So it's just an indication of what is in the pool, you could say. Another element is being shown up that will come in later on, I believe, as we take a look at adaptive forest management, is that larger trees tend to store more carbon. I took this from a tree carbon calculator, and it's very generic and pretty simplistic, but it kind of indicates that as the trees get older, if they don't get larger, they typically die. So let's say older, larger, and they tend to pack on carbon per year at an increasing rate. All right, we're at 6:22. We're moving along quite well. We've got the carbon markets. In my previous work, I worked at Cuba Resources, and there was an awful lot of interest in the carbon markets. And the traditional forest offset carbon market was quite a detailed, specific, long-term commitment. Basically, there was a 100-year commitment with most of them. The inventory work was pretty intensive, and you had to spend a fair amount of money each year to check that you were actually at a level that you'd basically sold credits on. But I always was surprised. It tended to be a bunch of very sharp, interesting people from a business background, and they were quite fun to speak with. They just had a different viewpoint on forests than I ever had. I learned quite a lot from them. There are, however, recently been a move towards a somewhat less regulated market. And there's a few different areas, a few different groups are coming up with novel ways of assessing how much carbon is in smaller land units, and how to measure them in an efficient way, and also how to cut the term of engagement down to somewhere where they basically might be more interested. Now I'm going to give 3 different ones in terms of what people might be interested in, but they're not in any specific order, and they're not I don't mean for them to be anything that the Maine Forest Service is suggesting you do. But if I was a landowner, I would definitely think about what they are, and how they might impact my work and forest management. One of the things that fundamentally they've shown is that if you can keep forests, you're locking up carbon more so than asphalt or cement. So the goal here might be, if you're very marginal in terms of being able to hold on that forest land, these programs might be able to give you a bit of a cash flow to keep things going. The first one is the Family Forest Carbon Program, and that's a collaboration between the American Forestry Foundation and the Nature Conservancy, and they're well-respected groups. So I would say that anyway, what I've done also is put the links to the sites so that you guys can see them. Basically, it's in a couple of 20-year commitments that might work for folk, and you can sell a couple of times your carbon there. The next one, Core Carbon by Finite Carbon. It's kind of interesting. Folk probably might have heard that British Petroleum have bought I think it's like a 50% share in finite carbon, which is kind of nice to think that one of the major energy producers is concerned about their footprint and wanting to help with the issue. And the last one is NCX, Natural Carbon Exchange. It's not carbon, it's Natural Capital Exchange. They're interesting in terms of their commitment is only for 1 year. They basically have come up with a methodology that uses remote sensing, and have created a very specific GIS map in which the landowner would go on, highlight the areas that they want to enter into the program, and it's a commitment for 1 year not to harvest. That group also is very interested in some of the other elements in forest management that aren't seen in the marketplace yet. Things like biodiversity, water quality, even maybe aesthetics. How to provide value to a landowner who's providing value to the larger society in some of the areas that don't have a current market. I don't know whose one's best. Just feel free to go through the links, see if anything works for you. Most of these are voluntary markets. They aren't, as I say, quite as rigorous as some, and there are verifying agents out there that basically set themselves up and say, yeah, we've looked at this program and it is it's sensible and it works. The first couple, I mean, the first and the third one, I know still have to be verified by that program. I'm uncertain if core carbon has actually met that standard yet. So it's a little bit early, but they definitely are have the potential for helping folk who own fewer acres than, say, 10,000 acres enter this marketplace. Having said that, there are some questions about the validity of the newer voluntary markets, and the idea is you want to make sure that you're not causing problems elsewhere, you could say. For instance, if you lock up cutting down your large wood and the sawmills go hungry, are people going to turn to metal studs or cement, which the carbon footprint is a lot bigger? There's the question about quality. Are the standards rigorous enough to really hold up? That's basically why they have the verification bodies out there, to make sure that they are. The additionality question comes into it in terms of, are you actually changing behavior within this marketplace, or is it actually rewarding something for what they would have already done? I'm a bit neutral on that one. I think if you're providing the service at any level, maybe you should be compensated for it. And then the last one is a question of permanence. Are you locking up the carbon for a meaningful term? I know that the 1 year deal is interesting, but is that meaningful in the long term of things? So that's a real quick run through the carbon markets. As I said, I think Alyssa already posted a lot of these on the chat, and then we can basically get to questions. So bear with me and I'll fire up the questions. Or were there any? Oh. Scroll up for links. There we go, Alyssa. Thank you. Well, I think basically I got my half hour in, and anytime anyone wants to get in touch with me, feel free to check out the Maine Forest Service site. And as we go on, the question of carbon in forestry is going to get more and more, speaking like an MBA, more and more interesting space. And I know that the Forest Service will probably be tasked with helping landowners meet their carbon goals. So watch this space. Thank you.